Hey everyone, David Twyble here. When we started this series on aerodynamics, we started out with the airfoil and its components. We identified it. Then we looked at angle of attack, which is the angle between the chord line of the airfoil and the relative wind. Last week, we talked about how much air is there, and that's about 400 quintillion particles of air in a 1 cubic inch space. That's a cube with 1 inch on each side. Now we need to continue talking about air to better understand it so that we can understand how the air interacts with the airfoil in future episodes. And the first thing we need to understand is density, specifically the density of air at sea level. And we're going to get to that, but let's illustrate density first. I have a clear container here that has 500 blue beads in it. And if we shake this container and those particles are flying around in there, that's a basic simulation of what air is. It's a bunch of molecules flying around in space constantly. Now this container containing 500 blue beads is approximately 20 cubic inches in volume. And we can then determine the density by dividing the number of particles by the volume of the space itself. So we take 500, we divide by 20 cubic inches, and we end up with 25 particles per cubic inch. So when I was shaking it, and they're all flying around in there, each cubic inch had approximately 25 particles in it at any given time, on average. And so that's a small amount compared to how much air there actually is in space. And we determined that last week, 400 quintillion in a cubic inch. But we don't want to talk in terms of billions or millions or quintillions or trillions. We want to talk in easier numbers when we're talking about air density. So we have this thing called Avogadro's number that you may remember if you've taken a chemistry class. And it's 6.022 times 10 to the 23. That's 6 followed by 23 zeros. And if we have that many of something, then we have what we call a mole. M-O-L-E, a mole. And if you had a mole of pennies, you would be probably the richest man on earth, right? So it's literally just a counting of a certain number of particles. And so this is far from a mole of particles right here in my container, blue balls. And so let's think about what that works out to. So if we have 1 mole of air at standard sea level conditions, that works out to filling about the size of a basketball. So if you ever pick up a basketball, you're holding approximately 1 mole of air. And it's literally just telling you that there are 6.022 times 10 to the 23, or roughly 6 with 23 zeros following it, number of air molecules in that basketball itself. Now the cool part is, it doesn't matter if we take that basketball to the bottom of the ocean or to outer space or to our next door neighbor. It doesn't matter where we take it, as long as the size stays the same and we don't let any particles in or out. The density inside that container does not change. So that's all density is. It's the number of particles in any given space. Now, we simplify that even more to what we call pound mass. And pound mass is very simple. It's just a connection between moles and a given substance like oxygen and nitrogen in air. So if we have 1 pound mass of air in a given space, then if you weighed that pound mass here on Earth, it would show a pound on a scale, but the scale is showing a force. A pound mass is just a connection to how much stuff there is. So if you take that pound mass into space and you're floating in free space, you still have pound mass because it's about the number of particles. It's just a way for us humans to simplify things so that we don't have to talk about huge numbers. You You can take that pound mass anywhere in the universe, and you'll still have the same amount of particles. And then if it's all in the same space, then you have the same density. Now, in aerodynamics, density is constantly changing. And so it's not always just as simple as one density. But density is very important as we look at how airplanes perform and how they work aerodynamically. And so we're going to run into this concept of density many, many times as we dig deeper into aerodynamics. So in future videos, we'll talk about a few other different properties of air, and then we'll get back to the airfoil and its interaction with the air itself. So until then, fly safe.